So energy use and GWP, I'll try not to, and I hope I haven't used too many TLAs, as somebody told me, is the best term for three-letter acronyms. So I hope I'm not going to use too many three-letter acronyms. GWP, I will explain that one, is just global warming potential. So if you look at all the greenhouse gases coming off a farm or a production system, and you put it all together, you can call it, in an integrated way, the global warming potential. So that's a little bit separate from energy use, just energy use in the farming system, but they are related. So let's start with that one. So what we did with the Roundtable Study was to look at, and the interest from the Roundtable point of view, this was not just an academic exercise, was really, nationally, can we get up and brand organic as being of benefit in terms of energy use? Can we go out to the consumers and say, we're pretty confident we have evidence that if you support organic foods, that you're supporting a low carbon, a low energy type of production system. Is that true for field crops? Is that true for horticulture? Is that true for livestock production? Can we break it down? So it was really a branding exercise as well as a sort of research exercise. So we were looking at all the greenhouse gases, if we could find evidence on greenhouse gases, and farm energy use, all rolled into global warming potential. So what we did was look at the literature. We were trying to find primarily Canadian literature or evidence, and then if not, North American, and then we would go further afield. We ended up looking through 130 papers, which is fairly extensive, and then broke it down as much as we could by sector, by field crops, beef, dairy, hogs, poultry, vegetables, fruit, greenhouse. We also looked at what we might call cross-cutting issues, issues that are common to many farming systems, tillage, composting that we do a lot of in organic systems, soil carbon. These crop up, and they're great issues of concern to, of course, to organic farmers. And then the broader picture as much as we could to sort of, but the focus of the study was farm scale. So we were looking at just at the farm, we were asked to look at the whole farm level, what's the sort of carbon footprint, the climate change footprint of the farm level. How easy was it to find information on this? Well, this is relative proportions of sort of literature, scientific literature that was out there. There's quite a lot, or relatively more on field crops, which I think to many of you will be of interest. And quite a number of those are very well done Canadian studies done in Western Canada, where they literally looked at the total energy cost of if we were using tillage, if we were using green manures, if we were not using nitrogen fertilizer, put that all together. So there's some excellent studies from Western Canada on field crops. Beef, dairy, there were more of these types of studies in dairy, but you can see in some areas poultry, greenhouse, there's really very few studies that have sort of compared organic greenhouse production with conventional in terms of energy footprint or climate change footprint, poultry was another one as well. And as we went through the information, it really varied. The approach the different studies took really varied. The first thing that we were really struck by, and the first thing we wanted to find, was what's the typical energy use across the whole food chain. So if you go right from the farm to the table, the consumer at the consumer level, what's the energy cost of the farm level, the processing level, the retail level, transport? Is there a Canadian work that's really tried to look at the food system in Canada? And amazingly, we couldn't find anything that had really broken that down by looking at whole food chain, as you might call it, analysis. There's an excellent study just published this year in the US where they've done just that, and we cited it a lot. We used that as kind of a benchmark. And in general, that study in the US, no matter what kind of production system you were looking at, whether it was livestock or field crops or horticulture, showed that the farm had a big contributor to the energy cost of a food product at the consumer level. The farm was typically 35 to 50% of the energy inputs, sort of embedded in that food product. So it's that really justified what we were doing, to look at the farm level energy efficiency. So as we went through the data, there were lots of gaps, as I just said, in the data for some sectors. There was always differences in how these studies were done. Some of them were looking just at energy efficiency or energy use on the whole farm. Others were looking at also the greenhouse gases, or GWP. And some of them took very different approaches how they did that. LCA is, after saying I won't use acronyms, LCA is life cycle analysis, so they're much more sort of integrated approach to it. So we have to sort of wade through that very different presentation of the data. And so inconsistent methodology. Do you credit soil carbon? Do you decide that soil carbon is an interesting part of the calculation, or is it sort of neither one or the other? It's a small influence. You have to, not all studies differ in how they approach that. And then very importantly as well, how did they report the results? So let's say if you had a farm that was less energy use per hectare or per acre, is that also true if you reported that per product, per kilogram of grain, per kilogram of beef? Is it? So are we talking about on per land base, or in terms of efficiency, the energy use per product? So we tried to do both. We tried to summarize all the results and look at it in both regards. So in terms of just general, very general, this is a large study, and it should be publicly available now. It was submitted to Ag Canada. It's a 54-page report and broken down by sector. And we're trying to get the information out, and I'm very glad to be presenting it here. It's only recently finished. But there's a lot of detail in it. But the take-home message was that almost across the board, organic systems use less energy. Now, what do I mean by that? I'm not talking about just fuel consumption on the farm. We're looking at all the energy use on the farm, including the inputs. And one of the biggest inputs of conventional farms in terms of energy cost of the final food products, of course, are things like nitrogen fertilizer, pesticides, herbicides. They all have an energy cost, and quite a high energy cost. But that would include in livestock concentrates, etc. So the organic comes out ahead almost across the board. It didn't matter what sector we were looking at. Organic came out significantly ahead, meaning 20 to 50% more energy efficient and more less energy use in total. And some of these, as I mentioned before, some of these studies, some of the evidence for this is excellent studies done in Prairie Province, long-term 6-year studies comparing no-till systems, minimum-till systems, organic systems, such as Stock Research Station, etc. They tracked the tillage, the amount of tillage in great detail. So there's quite convincing evidence on this. It'd be nice to have more. It's always nice to have more evidence and more Canadian data. But there's definitely a picture that we can go forward with. If you try to do it on a global warming potential, remember that's not just the energy of the carbon, it's also methane, nitrous oxide, the other greenhouse gases that you probably heard about. And you put them all together in a sort of CO2 equivalent per product or per hectare. It's not quite as definitive for in terms of organic clean ahead. It varied by sector. But here we're on even less solid ground because you get into fewer studies that have actually been able to measure the greenhouse gases or estimate the greenhouse gases. Energy is actually not that difficult there's reasonably good estimates of a particular tillage practice is going to use this much energy. We've got fairly good data on that. But the tricky ones are methane and nitrous oxide. We're still really in early days in terms of trying to get a handle on what systems, what management practice, what kind of greenhouse gas emissions do we get. So we sort of summarized in the report that branding, if we're to brand organic, Canada Organic, on energy, we're on fairly good brand. But if we're going to brand more broadly on global warming potential, whether you do it per hectare or per product, we'll have to be a bit more selective. We'll have to it's only in some sectors, some production sectors, that we have fairly good data. But still, overall, this was very encouraging, and it was really a credit to the Roundtable and AFC to sponsor this work. We also, in the study, had a chance to look at some common myths. You know, that transport is a major contributor. We've been talking about that here today, this idea that, or yesterday, there's been quite a bit of talk about the local food movement. Isn't it better to go with local food because it's lower energy or lower carbon footprint, you hear it put that way, or it's lower energy cost. But if you look at that very comprehensive US study, and that was a USDA study where they broke it down by sector and looked at the carbon footprint of the farm level, the processing level, the retail level. There's lots of carbon energy used at the retail level and cooling, etc. Even at the household level, and then the transport. Across the board, on average, transport was 11% or 9% of the carbon footprint of a food product. And it didn't matter whether you're talking livestock, horticulture, or so it's a very small contributor to the total carbon cost embedded in food product. You don't have to just go with the US study. Very recently as well, the UK did a comprehensive look at this. It's called Food 2030, where they want their food sector to be in the next 10 to 20 years, and they did estimates, should they spend a lot of time worrying about food miles, and they found out that the carbon footprint of transport was 11% of the, so in other words, if you're seriously talking about reducing the carbon footprint of any agricultural product, we really should be focusing on the farm level and on perhaps the processing level as well. And if we're in organic, we're already ahead of the game. What about this idea that organic farmers are using lots of energy with the added tillage they're doing, and that this is a major part of the energy use? And again, thinking of energy use on the farm, not just in the sort of more practical, farm level fuel consumption side. This is a very holistic idea of all the inputs coming into the farm being the energy embedded in those as well. So if you look at it in that more holistic picture, tillage consumption, or tillage use of energy is often a negligible component. I know that might sound surprising, but if you look at the total energy used in terms of all inputs, etc., and farm practices, and these are, Zettner's study is out of, I really recommend that study by Zettner. It's at the Scott, based on the Scott research station for 6 years, and they also concluded that tillage, the type of tillage, was negligible in terms of whether the total energy consumption, which what was much more important was whether you were using nitrogen fertilizer, the type of crop rotation, etc. Those were much more important.